Gentlemen, welcome back to the shop, and sorry about not making any videos for like 2 weeks. It's been busy, but obviously that's no real excuse. We've got this solar panel here that has been kind of in the way, and a couple months ago now, I lifted this out of a bin and asked you what could I do with it. It's broken, shattered. And the general consensus is basically it is not salvageable. You cannot really replace the glass. So what I'm going to do today is we're going to put this panel out of its misery and also freeing up some much needed space in the garage. Of course, first things first, we're gonna see if it still has any juice in it, so let's just see. It is in full sunlight, and it's definitely outputting a voltage. Now the interesting thing, of course, is the sun is coming out, voltage is going up. And it seems fairly normal. What's the nominal? Yeah, it's 37 volts open circuit in full sunlight. So yeah, wow, it's still basically outputting nominal power. It's now at 4.5, almost 5 amp short circuit. Yeah, we're now at 6.5. We're actually at close to the continuous reading of this multimeter, so I might just not tear this panel down. It seems like a waste. So I was actually pretty surprised that the solar panel still worked. I was kind of ready to tear it down and take the cells themselves out, but this is just a waste. So it kind of makes sense to revisit these again. So I'm very sorry for keeping these in the box for so long, but it does make sense to try and fix these and try and find the problem. So the owner of these solar inverters actually contacted me again. He found a hint of what might be the problem. There are a couple of Zener diodes on the AC end that possibly, or actually on the DC link side, the high voltage DC link, and those might have failed, and if they have, we might be able to repair this fairly easily. So let's take a look. So apparently the offending parts are these diodes, these D59 and D60. One of which, let me see, yeah, one is a 300 volt Zener and one is a 250 volt Zener. And apparently these tend to fail. The way a Zener diode works, Zener diodes are much like normal diodes. A normal diode has this maximum reverse voltage that you can put on it before it fails. And the way it fails is that it goes in what's called avalanche breakdown mode, where a small current path is created through the diode, just a small path where the excess voltage causes the dielectric effect of a semiconductor to break down, and then that sets off a larger conduction path. And in Zener diodes, this is more controlled in a way that you don't actually break the silicon diode. In various methods, just through the type of doping and the geometry of the diode, you can make it so it fills in a controlled manner and in a way that has a very precise breakdown voltage. However, Zener diodes, especially power Zener diodes for these kinds of things, you are still dissipating. For instance, if this is a 250 volt Zener diode and at some point it has conducted just 1 milliamp, that is 250 milliwatts on the die. It's a very small component. It will heat up the dopants will migrate, the leads might develop micro cracks. There are a lot of ways in which a Zener can still fail. And especially if used as advertised, but for instance overstressed, or it encountered high temperatures. And of course this kind of application does endure high temperatures. So I wouldn't be surprised if these fail. Well, have you? This actually, there might be some other failure. Here, I was looking over the board while also looking at the diodes, and actually this chip U21 seems to have failed. There's a blowhole in it, so I might just look at the other. I have two identical inverters which have the same problem. Might look at the other one and see if this is blown as well, because that would indicate some other failure apart from the diodes. By the way, according to the forum post that I was referencing, this is indeed the revision that has the bad combination of Zener diodes. Could not actually measure a fault with them, so they might still be good, because this has a 47 ohm resistor here, and apparently this has been changed to a 120 ohm resistor, i.e. reducing the load on the maximum current going through these diodes in later revisions, and also increasing these Zener diodes to 300 volt models both. So this is definitely one that's vulnerable, so I will be replacing those diodes, but I will also be looking at this chip, and that is actually an IRS 21814, which is a dual MOSFET driver. So that's definitely busted, and it's a very important part of the circuit, so that's going to have to be replaced. And the other inverter doesn't seem to have this problem. Also measures exactly the same on the diodes, so I'm not sure if the diode theory still works. However, I'll order some parts and replace the diodes on both, replace the MOSFET driver on the one that has failed, and we'll take it from there, I guess. Well, it's a day later, and I guess about $12 short, and I have replaced the MOSFET driver with an analog. They have 18 different models, and they differ in minute differences, so I guess this should work. And I have changed the two Zener diodes with 3, because actually finding 250 or 300 volt Zener diodes is pretty hard. And they were only selling up to 200 volts at Farnell. So I just put 3 in series and put some Kapton tape underneath to insulate them from the pads beneath. I've hooked up the solar panel, but unfortunately it's quite cloudy. But more importantly, no power is produced. This is a modded power meter that I use for just quick checking. And yeah, the sun just broke through, and there's like less than a watt of power being consumed or produced. This meter is not accurate enough to say. So there's probably more wrong with it. And I would say that that blown up MOSFET driver probably had some repercussions down the chain. So I'm gonna have to see if we can fix that. Yeah, so I've actually tried both, and you can hear they still have this high tone that actually changes with the insulation, so with how much sunlight is on the panel. The panel voltage is correct, so that's not a problem. It's definitely these inverters that are doing something wrong. So both of them are acting the same way, making noise but not actually producing power. Now this is kind of interesting. I've had this running for like half an hour, and it's actually gotten really hot, even though it hasn't produced any power. Clearly it is dissipating the power like in this and this general area, which seem to be just by their location. This is the MPPT section, the MPPT and step-up transformer. So this is kind of interesting. Why would it dissipate so much power there when it's not actually producing any output? Well, so I guess the next real course of action is just to plug it in like this and take a look at the thermal images to see if there are specific components that are really heating up. And also this way I have access in a relatively dangerous way, but that's good, to all the solder points on the bottom side, so I can possibly look at the output voltage. Yeah, so as you have probably seen in the thermal video that I embedded, it is this transformer that just gets mad hot immediately after you plug it in. And it was also fairly clear from the images that the source of the heat was the windings. So this is a little bit weird. This would imply that somehow we're dissipating pretty much most of the energy in the windings of this transformer, but how? If I look at these diodes here, this is the secondary output of the transformer, and if I measure the voltage drop over these diodes, I'm actually measuring 0 over these two. These two seems to be fine, but this seems to be 0, and this, for all the world, just looks like a bridge rectifier. So there shouldn't be a direct connection between, say, the ground and one of these poles. So starting to suspect something might have failed. Either these diodes, one of these diodes has failed, or something down the line has failed that causes pretty much a dead short here. Hey, those diodes are busted. Maybe that's our fault. Let's try and replace those. Alright guys, I'm a bit sorry about the sketchy videos and handheld and just saying what I did instead of showing what I did, but long story short, it was kind of a pain to get all this apart and together again. Put in the transformer again. I put in 4 diodes, 2 parallel, because all I had laying around were 600 volt MBS 1Gs, 1 amp diodes, and I think these are 3 amp diodes, so I hope this gives enough headroom. Just to test it out, I will be ordering higher rated diodes, but I really just want the unit up and working today. So let's test it out. Well, if anything, it's not making any noise anymore, so something changed. But at the same time, no real power is being made, so definitely not fixed yet. It's also buzzing again, so maybe the diodes I put in have failed already. There is like 550 volts in there, so... Well, it is again a day later. I am just coming up short on this inverter. I have found a couple of issues. For instance, so if you look at the topology of the inverter, the DC power comes in here, goes through some filters, goes into a half-bridge forward converter type deal, gets up converted to something like 525 volts actual voltage here, then goes through just a simple buck converter, really, a transistor and a diode, and this enormous inductor. This is actually all just a single filing inductor, which obviously converts the DC high voltage to an AC, and then goes through some output filtering, and that's it basically. I found that on both units, the output rectifier of this stage has failed. I found that on one of the inverters, the MOSFET driver, the MOSFET, and actually the diode as well, of this buck converter have failed. And interestingly, even though they have slightly different failure modes, they both have the same symptoms of this. When it starts up, there's just this buzzing sound and no actual output power. I'm not quite sure what the real problem now is. I have one of these units is permanently defective. I extracted some components to replace stuff in the other, for instance the MOSFET and the diode, and I have tried multiple things. Like there have been, I think, 5 or 6 takes of other tiny things I found and I fixed that apparently weren't the cause. I've spent quite a lot of time on this just over the days, so I'm going to publish this video. Maybe some of you have ideas what to attack next, but I think it's quite a bit more complicated than just single component failure. I think there are some consequent failures that are messing this up. Anyway, thanks for watching, and hopefully next video we can actually fix these instead of having these slightly disappointing videos. See you next time!